Hi, my name is Jason Chan. I'm in Math 32 in the sixth discussion, and my presentation is on estimating numbers in populations. So first we have to understand what mark and recapture population statistics are, and in order to understand that, we have to take a look at a very simple brief description of what it is. So mark and recapture is basically a method where a group of small population is group tagged, then released and recaptured in order to estimate the statistical probable sample size. So say in a forest, for example, if we have a group of weasels that we're trying to estimate are in this forest, but we can't, of course, capture all the weasels in this forest. We can just group and tag a small number of weasels in this forest, release them and recapture them to estimate what the likely total population of the weasels are in this forest. So we'll see that in this picture below that a animal is tagged, and that's what we're using it for. And so first we have to take a look at the formula that is involved in this. And the simple version of it is that it's denoted by M equals MC over R. N stands for what we're trying to find, which is the estimated population size in this forest. M is the number of marked animals in the first catch that we tag. C is the number of recaptured animals in the second catch. And R is the total number of animals caught in the second catch. So we can see actually a more accurate representation in the picture below. M is the first tagged animals, and the second circle represents the second catch in the total number of animals. And based off the circles that we see, we can better understand how this formula represents and is put to use. And so a few necessary assumptions that we must make in order for this formula to work is that the tagged group must be allowed to freely intermix with non-tagged groups. Also, statistically significant percentage of the population must be tagged, which means you can't just catch one animal, tag it, and release it. A significant percentage of the population must be tagged, at least enough to raise confidence in the amount that we recapture later. And the tags must not interfere with the survival recapture percentage chances. So say if we capture a group of sheep and we put bells on them, if they all get hunted because of the tags that we use, then it would not be a fair representation of the population size that we get later on. So we can better understand this formula through a few examples. And so a very simple example that I put in is actually used quite often in estimating the amount of, say, salmon or the amount of fish being affected by a dam. So for example, if we catch 20 trout in a given pond to mark, and a week later we recapture 50 trout, and in that group of 50 trout, 5 of them are marked from our first catch, we can estimate this population to be what? And so by using MC over R, we can actually estimate 500. This is because we multiply 20 by 50, 20 being the amount of trout that we caught in our first catch, and 50 trout that we caught in our second catch, and we divide it by 5, which is the amount of trout that we caught in both the first and second catch. And if we do that math, we actually get an estimation of around 500 trout within that pond. And so this is actually very useful in real world relations, especially in the world of science. So in the world of science, it actually allows for an accurate estimation of large populations in a very realistic amount of time with high accuracy and confidence. And so we often see this actually in estimating endangered species, especially since it's so hard to catch. This is a very good method to predict with high confidence the amount of endangered species in a given area. And also in very large scale applications, such as in the current pandemic, without having to actually count each person who is affected, and since it's always ever changing, we can just go ahead and mark the amount of, say, hospital visits or active cases that we know in hospitals, and based off of that, we can actually predict how contagious a disease is, how likely it is to spread, and how many people have the disease at a given time, with given factors. So actually, we can actually build upon our formula to create a more accurate representation, and we can take a look at that on our next slide. So if you remember, our first formula only takes into account one capture and one recapture, and sometimes the first or second recapture may be an anomaly or extremity. So in order to make sure that we have higher confidence, we can actually take into account multiple recaptures, multiple captures, and we can see that denoted by our formula below, n equals m2c2 over r2, r3, etc. And so M2 and C2 obviously mean more first and second catches. And so therefore, by taking more and more captures, scientists can be more confident that the recaptures that they received was not just an extremity or anomaly. Thank you so much for listening to my presentation. I hope that this has been interesting and it's made sense.